Okay. I think usually there's a countdown. Maybe it doesn't. Okay. Yes, I think we're live. Great. Hello, everyone, and welcome to I can hear myself. I have the video on next to me. Hello, everyone, and welcome to a very exciting event, which is the first of its kind here on my channel. For the first time, I have not one, nor two, but three distinguished guests here to engage in a discussion all about fine-tuning. In this discussion, I want to cover a wide range of aspects of fine-tuning, from the meaning of the term and the evidence for it, to what a good explanation of fine-tuning might be, and possibly whether we need an explanation at all. So joining me are three experts in the field, all with very differing views at times. So I'm sure this will be an informative and hopefully fascinating discussion. So without further ado, let me introduce my guests here today. First of all, we have Dr. Luke Barnes, who is a theoretical astrophysicist at Western Sydney University. Luke has written plenty on fine-tuning, including academic papers and a book called A Fortunate Universe, along with Geraint Lewis, who is also here today. Geraint is a professor of astrophysics at the University of Sydney and has written about fine-tuning, especially with regards to how science and the multiverse hypothesis may explain it. And finally, we also have Philip Goff, who is an associate professor of philosophy at Durham University. He mainly works on panpsychism, philosophy of mind and consciousness, but I understand you recently taken interest in fine-tuning arguments. So good to have you on here today. Before we jump into the discussion then, probably just worth saying very briefly, what is fine-tuning and why have we all gathered to discuss it here today? As I understand it, fine-tuning is a claim about some of the fundamental quantities or parameters that govern our universe, that aren't predicted by our physical theories. That if we were to change the values of these quantities, even by a tiny amount, intelligent life would not be able to exist conceivably at all. What is then inferred from this is that the existence of life is a miraculous or astoundingly improbable fact which cries out for an explanation of some kind. The possible explanations proposed for fine-tuning touch upon physics, theoretical physics, philosophy, and religion. And so fine-tuning offers a fertile area for discussion between scientists and philosophers with wildly different worldviews, which I believe is the case for us today now. So enough introductions. Let's jump right in and try and understand exactly what fine-tuning is, what evidence supports it, and what may be able to provide a satisfying explanation for it. Okay, so the first thing I want to discuss is this question here. What does it mean? What does the term mean at all? What does it mean for a universe to be fine-tuned? And what I think is a good definition to start with is one that was proposed by Luke Barnes in one of his papers, and it's on the screen now. In the set of possible physics, the subset that permits the evolution of life is very small. Luke, do you want to say a few words about this as a definition?
Yeah, so I should say that's the fine-tuning of the universe for life. Fine-tuning as a term used in physics is slightly more broad than that. What we mean is that in order to explain something, usually some data, which is what we love to do, explain something, a theory has to make a suspiciously precise assumption. So there's your idea about how the world works or some part of the world works. But in order to have it match up with the data, you're having to take some knobs and dials behind the scenes, free parameters usually, and with one eye on the data, just sort of make sure they're all in just the right place in order for the predictions to be right. And that's generally thought to be an indication that, it's an opportunity for another theory to come along that doesn't have to do that sort of stuff behind the scenes, to come along and explain things better than your theory does. So it's a potential weakness. What we discovered was what sort of physicists, astrophysicists, cosmologists discovered over the last sort of 40, 50, 60 years maybe, is that if the thing we're trying to explain is how our universe is able to support life, and the knobs and dials behind the scenes are the fundamental constants of the best laws of physics we have, then the universe does appear to be fine-tuned for life. If you want, your atoms to stick together or your universe not to expand ludicrously quickly in the first fraction of a second, you need these dials to be not exactly where they are. There's a little bit of room for movement, and there's some weird dials that actually you can change quite a bit, sort of weird properties of neutrinos and such. But there's a fundamental core of these dials, these numbers, that you need to get in a fairly small subset.
Okay. So when we're talking about the fine-tuning of the universe for life, then looking at this particular definition, what do we mean exactly by the set of possible physics?
Well, when you're trying to explain the way the world is, there's equations, and we see numbers in those equations like the fundamental constants. And if we can measure those, so the mass of the electron, but I'm perfectly able as a theoretical physicist to take a set of equations and say, what would the universe be like if it obeyed that set of equations with, say, a different set of numbers in them? In fact, that's exactly what theoretical physics is. The possible physics there is our attempts to explore, sort of in the neighborhood of the way our universe works, other possible ways it seems like it could have been. Certainly, there's nothing in physics that say mathematical inconsistency or something like that. There's nothing like that around to tell us that these other ways the universe could have been are ruled out. So the possible physics there, it's a slightly loose term, to be perfectly honest. But the idea there that we can explore other ways the universe could have been.
Do you think we should be careful, perhaps, sometimes in maybe whether just by varying some of the constants, varying some of their values, whether the values we might be varying them to may turn out to be values which couldn't have been realized in nature and so aren't necessarily possible?
It's possible, but there's two things there. I mean, what is it that's going to come along and say, okay, that value of the electron mass, there can't possibly have been a universe like that. If it's some higher level law of physics that explains even more than the laws we have, say higher or deeper, it depends on the the analogy you prefer. If there's some greater, more explanatory, as yet unknown law of physics, then yeah, bring it on. That'd be great. But the one thing that you're never going to get out of physics, especially, is some sort of, say it cannot possibly be like this. I mean, physics will tell you how the universe is, but not how it must be. That must is sort of I don't want to dabble too much in philosophy here, but the modal, some sort of necessity here. That's not what physics deals in.
Okay. So then the other part of this. Oh, yeah, go ahead.
Sorry, am I allowed to take a step back? Because often fights over fine tuning begin right at this point, and there's an important issue. There's an important issue that's been left out of this, and that's the issue of asking the if question, right? And so physics starts with an if question, and the if is, if the laws of physics could be different, what kind of universes could we have? And that's our starting point. And people forget that if is there right at the start. And somehow things run very, very fast and arguments become definitive statements about other universes with forgetting that initial if. So I agree with everything that Luke has said there, but we must remember that it's and that's, I said, that's why all of physics starts by asking if questions. What if an electron has a wavelength, right? That kind of question you can ask, and then ask what are the consequences. So it's a starting point, but I said the fights break out at this point in these discussions.
Yeah, maybe I could just add a couple of things. I mean, I don't disagree with any of that, but I suppose looking there at the set of possible physics, I suppose, as a philosopher, I'm thinking, what is the limit of the set of possible physics? Presumably, there are infinite number of ways physics could have been. So we're not going to be able to get much of a theoretical handle on that. So I think what we do in discussions of fine tuning is maybe take a set of possible universes, and one straightforward way of doing that is to take the set of possible universes with our physics, but with the numbers different, and say, you know, in that set of possible physics, that set of possible universes, how likely is life, or whatever. And some people then have the intuition that seems like it's cheating a bit, but I think there's a straight. We haven't got on to. We don't want to get too technical too quickly, but in Bayesian reasoning, there's a straightforward way of doing this in terms of, you know, what you put in the background information that you're already assuming, and like any probabilistic reasoning has to do that. So I think it's not, as long as you're not cooking the books by picking a really contrived set of universes, I think it's totally fine to say, look, we can't consider any possible universe, and to take some non-arbitrary, non-contrived set like that. And just another quick point, you said, Matt, well, how do we know these numbers could have been different? But again, in probabilistic reasoning, I don't think you're dealing with possibility as such. You're dealing with what we call epistemological possibilities, like how things might have been as far as we can know. So I think that's it's good to be clear from the start. That's the kind of probability we're dealing with. So yeah, as Luke says, if some theory came along and proved these numbers couldn't have been different, and that's going to factor into our probabilistic reasoning. But until that does, we've got to have on the table the scenario in which the numbers are different, because that's how probabilistic reasoning works. It works with how things could have been for all we know.
Okay, great. Yeah. Oh, yep.
Can I muddy the waters even more? So you know, even if we do one day come up with a theory of everything where there's no more freedom anymore, and the mass of the electron relative to the mass of the proton is set by pi's and e's and all this kind of stuff, right? So there's no more freedom. We don't have to ask nature anything. We will still be left with the question of why this particular mathematical structure, right? You know, why? And then the question goes to another level, right? Because we need a theory of where our theories come from. And so, even I said, I personally, I would not be satisfied if we did have that theory of everything, because I would still be wondering why the right numbers to allow us to be here.
Yeah. Okay, good. So I think that's the first part of this definition addressed. The second part of it, so the subset that permit the evolution of life, is very small. Now, a lot of the times, especially when fine-tuning is brought up in a clash of worldviews between theism and atheism, for example, the claim is usually construed as being probabilistic, that life, it's not just that the subset that permit the evolution of life is very small, but that the subset that permit the evolution of life was very unlikely or implausible to be realized. The chances that we ended up in the life-permitting subset are very small, and that we should think of the existence of life and intelligent life as being very, very improbable. So I just wanted to ask how we can get from a subset of the set of possible physics being small to a probabilistic claim.
For me, I suppose, yeah. So the way I would do it is as follows. As I've put, this is from a review paper. It's 10 years old, mine, by the way.
I know, yes.
I've thought about it a lot since then. The way I would lay it out is something like that. This is our first impressions here. There's an enormous range of possible values of, say, the cosmological constant. There's a number that describes in our universe an effect on space-time or of stuff in the universe. We don't even know that yet. That causes the expansion of the universe to accelerate. It doesn't just get bigger; it gets bigger faster each day. There's a number there that describes that. As we look at that number in the context of the theories that describe our universe, the standard model of particle physics, standard model of cosmology, there's an enormous range of values that number could have. And if we start looking around in that range, at other possible values. We discover that almost all of them seem to, if you just sort of look at the range purely as it is, would either cause a universe that expanded so fast that no structure could form, or that collapsed so quickly that the universe is over in about a second. To turn that into a probability claim, I think there's more work to be done then. That's the stuff I've tried to do after actually my review paper. I think the most promising approach is, again, it's been said already, that this Bayesian idea, where the idea is we're trying to think of probabilities not as describing, say, populations and samples or anything like that. We're using the tools of probability theory to try to put a number on our own uncertainty, to put a number on how much one statement supports another statement in a way that there's logical arguments that are watertight. We can sort of water that down a little bit and say, there are clouds overhead, therefore it'll rain in the next half an hour. It's not proving, but there's sort of evidence. It's raised probabilities, lowered probabilities, and I think the subset that permit the evolution of life is very improbable. Depends on more than just it being small. There's got to be some idea about the universe that you're testing that's going to sort of generate these ideas about whether you think there could be a deeper reason for these numbers being what they are, or whether they are just brute facts, or whether, for the sake of let's just try out some ideas, let's just treat them like brute facts and see whether a brute fact universe seems to explain much, or whether it looks a bit unlikely. Small is a first impression here, and I think it's that impression that got everyone's attention. You've got to knuckle down a little bit more if you want to get down to probabilities, I think, but I think that can be done.
Mm-hmm. Mm-hmm. Any other comments from Geraint or Philip?
Do you want to say anything, Geraint?
Oh no, I was just going to say, but I mean, this is a topic Luke and I have spoken about an awful lot, right? In a very simple picture, right? You have a box, a multi-dimensional box of parameters, and you've painted a teeny region where you can have complexity and life, and that region is tiny compared to the volume, and that's the simple statement. But as Luke said, that's your first impression, but you do need more to work on probabilities. The other aspect of probabilities, though, that often makes this very messy is your priors and what people are bringing to the table. And of course, there are people who are unwilling to consider that the parameters could have any other values. They've got a delta function, zero everywhere else, and they cannot be shaken, right? So it's the usual kind of argument you have with probabilities, that there's not only the space that you're trying to work with, but there's what people are also, bringing as their prior. So, sorry, Phil.
No, that's fine. Yeah, no, I think we're all agreeing at this stage. I mean, another way to put what Luke said is we're not dealing here with objective probability, the kind of thing you get in certain interpretations of quantum mechanics, where you can say there is an objective probability of such and such that the electrons in this location. What we're dealing with is epistemic probability, which, to take an example of that, suppose you're on a game show and the prize is behind one of three doors and you've got to guess which. And that now you consider that the probability that it's behind gate C, you're going to say that's 1 in 3, right? Now, as an actual matter of fact, the prize is behind one of the doors, A, B, or C. So this is not objective probability. As in terms of reality, it's just 100% behind one door. But what we're working out is, as Luke put it, a sort of measure of our ignorance. What is the odds for all we know? For all we know, we'd say, well, there's 3 doors. There's a 1 in 3 chance it's behind gate C. And what's at play here is what's called the principle of indifference, where you sort of say, if there's no reason to favor one probability over the others, you divide the likelihood evenly. So there's 3 doors. We don't know which the prize is behind, so we say 1 in 3 behind each door. Now, you've got to be careful using that principle, but actually I think there are applications for it, and I think the fine-tuning is one of them, because we've got these constants considering that there's nothing in physics to determine the value of those constants, we ask, well, what is the probability it would have such and such value? Well, you take all the possible values in some possibility space and you divide the probability equally. So anyway, the important point is we're not here dealing with objective probability. We're dealing with this epistemic Bayesian notion of probability.
Great. I think we're definitely going to get more in detail into that, I think, a bit later. But for now, I think that's probably good enough for just addressing this definition. Now, I think we should say something very briefly about the evidence for fine-tuning and why we should believe that our universe is fine-tuned for life. So, what if Geraint or Luke would either? Oh, actually, no, Geraint, what you wanted to bring up first is you wanted to say something about what actually counts as evidence in this question of whether the universe is fine-tuned for life.
Yeah. I said it goes back to, well, I mean, firstly, we know that this universe is habitable, right? I think there's reasonable evidence that there is life in this universe. Not necessarily that intelligent, but there's life in this universe. And so we know that this is a habitable universe. And so the question of what counts as evidence, again, goes back to that if question, right? I mean, so we start off with the notion that we're going to ask this question about whether or not the constants can be different. And if that is a true statement, the constants could be different, then it is undoubted that our universe is fine-tuned for life, because the vast majority of those other universes is dead and sterile, right? So no, some people say, right, okay, that's enough evidence for me that there is a fine-tuning issue. But of course, we have a bigger problem here in that we're talking about this notion of there being other universes. And people go, well, you can't even talk about that because it's not science and you can't go out and test them. And therefore, they're not evidence in the way that you would normally have a scientific theory where you would run an experiment. But at the moment, of course, we don't know what real evidence means in this sense, in that we do not have a theory about the production of universes, or multiple universes even, and if they exist, are they truly causally disconnected from us, right? So I would say that the evidence from starting with that if question is that there is something interesting going on here, and therefore that should be the focus of scientists. And as you know, some people stamp their feet and say nobody should ever talk about fine-tuning in a scientific argument. But it's a starting point for the development of potential theories to explain where universes come from, and then explore within those what the observational consequences are. So I think, as I said, I don't think it's a clear-cut thing on what we mean by evidence right now and what might be evidence in the future.
Indeed. Any other comments on that?
There's a bit of a danger here. If the question was what counts as evidence of fine-tuning, there's a worry with the phrase fine-tuning, in that it's very hard if you take it. A lot of people take it literally and imagine a giant hand coming from the sky and turning a dial and then disappearing back up into the sky. It's unfortunately a little bit too there's a hand involved there. In terms of physics, all it means is, I was going to say, I don't know how to turn the word agent into an adjective, but it's a bit agential. It's a bit of that. So when we say the universe is fine-tuned, what we're talking about is a fact about the models that we use to describe the universe, which are our best handle on other possible ways the universe could have been, so far as we know. So in our curiosity to explore why, I mean, we live in a rather extraordinary place. If you go and look outside for a bit, why is it like this? Well, what other ways could it have been like? And then we go looking around that. But the evidence of fine-tuning comes from theoretical physics. It comes from, we can solve these equations and work out what the consequences are, even if I change the values away from the numbers as they are in this universe. So the evidence of the fine-tuning of the universe for life in the limited sense that it should be used, of just this dependence of the parameters, the evidence comes from the fact that we can do theoretical physics, that, what me and Geraint know how to do our jobs, that we can, for example, as we have done, solve supercomputer simulations of how galaxies form and look at the effect of the cosmological constant on that. That's the evidence for fine-tuning as this basic fact. In the context of a Bayesian argument, the thing that's evidence, as in the thing that goes into the likelihood, the probability of the evidence given the theory, that, like, in that context, the thing that we're trying to explain is the fact that our universe is life permitting. And so actually in this context, the fine tuning as such goes into the background evidence, the fact about the laws as we know them, that then tells us that the fact that our universe is life permitting seems to be a rather unlikely fact.
Can I add a little point to that? And again, something that gets lost is that this kind of argument is not new to physics, right? These arguments have appeared before for lots of aspects of physics. And of course, my favorite is the neutrino, right? The neutrino was hypothesized. I mean, there was two alternatives. Either energy is not conserved in radioactive decays, or there's another particle that doesn't interact with anything and off it goes. And so that was an observation that we had about our universe, and then there was a hypothesis put on the table, and then the question was asked, well, then if there is this particle called the neutrino, what's the experimental consequences of that? And then 30, 40 years later, people build an experiment sensitive enough to directly detect the neutrino. And the fine-tuning thing is a very similar thing. We look at the values of the universe. They do seem kind of peculiar, right? That's the observation. And as Luke says, we can play with the theory and ask what the consequences are. And we then put our hypotheses on the table, what the potential solution is, and ask ourselves what's the observational consequences for the future. And that's doing science. It's not something completely different to what's been done before.
Okay, good. So I think we will all be agreed that the actual evidence for fine-tuning from theoretical physics is actually very strong. But because we are having a fine-tuning discussion, I think it is worth just saying anyway. Geraint and Luke, do you want to give an example of maybe in your opinion, the most striking example of fine-tuning that we've found in research so far? Geraint?
Most striking. Oh, that's an interesting one, because at some level they all are interesting. And as Luke said, some of them are very narrow and some of them are very broad, right? And I mean, I've got my favorites. That's different to something being striking, right? And so
a favorite will do.
Favorite will do. So it's for me, it's the Hoyle resonance. I do like the Hoyle resonance for a couple of reasons. So the Hoyle resonance is this situation that when you're building up elements in stars, you take lighter elements and you smash them together. And in the 1940s and into the 1950s, right, they realized that the step before carbon, which is where you make beryllium, is a rather dodgy step, in that beryllium is very fragile and falls apart. And so when you calculate how much carbon you see in the universe, you've got to have, there wouldn't be enough carbon. Sorry, if there was only the beryllium interaction as people thought it was going to work, that would predict a lot less carbon than what we see in the universe, right? And there's this famous thing that Fred Hoyle saw this and said, right, we see lots of carbon, so there must be a state with regards to the nucleus of the carbon atom, such that it's got a particular state, the Hoyle state, particular rotational state, that enhances the rate at which carbon is made. And the location of that energy level is a balance between electromagnetism and the strong force. And there are arguments about how much you can change this, but you make it too high or you make it too low. You don't have the right route for turning beryllium into carbon. The thing that often doesn't get mentioned is that the next element along, which is oxygen, lacks that state. And so what happens is that you create carbon and it doesn't all get converted into oxygen, because oxygen, its balance of states lacks one of those. And so we end up in a universe where carbon and oxygen are two of the most abundant elements because of these states. And it's not just the one of them, there's the two of them. And we would have ended up with very different chemical abundances. And we could have gone too far and just had very heavy elements, or we wouldn't have gotten up to carbon. And we would have had different prospects for complexity in the universe. But these two states there, as I said, it's intriguing. It's one that I like. I'm not going to say that it's the best, but it's the one that I read over and over again. And I think, that's kind of interesting.
Great. Luke?
I like, it's sort of related to that one, but in terms of the fundamental parameters, it's just there's three particles we're made out of, roughly. Right? There's electrons, which you might have heard of, and then there's the up quark and the down quark. Those two together make protons and neutrons. And a fundamental property of these particles is just their mass. How much do they weigh? Right? Put them on a really little set of scales. And you might just think if you change those numbers, all you would make is slightly heavier atoms or slightly lighter atoms or something like that. But actually all hell breaks loose. It's kind of great. In the book, not that other excellent one over there, which is also wonderful. I try to map this out in sort of 3 dimensions if we change these 3 numbers. And it's one of the remarkable things is if you just map out in that space, where do you need to be in order to have fundamental stuff that sticks together in more than sort of 2 pieces, that you can put more than 2 things together, or maybe 6 or 7 or something, to make fundamental particles. And it's a remarkably small set, and there's us in sort of in the middle of them. But elsewhere, you put the most stable thing you can make out of the quarks is you have 3 up quarks stuck together, and that has the chemistry of helium, which is to say no chemistry at all. It doesn't only undergo any chemical reactions, but it won't then stick to anything else to make anything bigger. And so your periodic table is one useless element, and your chemistry textbooks never get written. So that's my sort of favorite example, just for all these different criteria. And hang on, I need that not to fall apart, this not to fall apart, that, and then this, and then you just land in this tiny little spot in the overall space.
Okay, lovely.
Is it just worth? I mean, I'll leave it to the scientists here. I'm not going to add anything on the science, but is it just?
I was thinking of asking whether you wanted to contribute an example.
Well, actually, I'm the fine-tuning chapter in my new book. Geraint and Luke very kindly read to point out my mistakes. So obviously, I'm not the scientist here, but maybe it's just worth emphasizing that comes up a lot. Something that is entailed by what Luke just said, which is that this isn't just about carbon-based life. That's such a common reaction. People bring in this very tired Douglas Adams puddle analogy. Oh, this is just about the kind of life we are. And as I understand it, some of it's about that, but like the example Luke just gave, it's about getting any kind of chemical complexity at all. A lot of these variations just have hydrogen, the simplest element. So I just think it's important to emphasize that, because it's such a common reaction to these fine-tuning arguments.
Yeah, it's got nothing to do with us. So anthropic principle, nothing to do with us. And we've had this argument before as well. So you're right. It's about whether you can have complexity.
I think one of the
if I hear that Douglas Adams puddle one more time, I'm gonna throw my laptop out the window.
I think it's out of context. I don't think it's about fine tuning. Anyway, another.
Yeah, we got so sick of that article. Yeah, we got so sick of that article. We wrote a response and had it published. I mean, we got so sick of people putting that on the table and going, "Aha!" And it's like, "Oh, not again." Anyway, sorry.
Well, I think one of the counterpoints to this sometimes that's raised is that there are very, very simple systems which do seem to show signs of complexity. And then Conway's Game of Life is held up as the paradigmatic example of that. But as has been, well, I think I'm probably going to say what your objections.
No, please say it.
But the objection for that is that if you look in the space of all these different, if you look back at when Conway and co were coming up with these games, coming up with these systems, most of the systems didn't work. They had to stumble across very particular rules that would generate any kind of complexity at all. So in a way, we actually have at least one environment where we could say, there's something that isn't COM-based life at all as an example of life, or at least complexity that we can study and learn a bit more. But it's the same kind of problem with COM-based life and the laws that seem to govern our universe, that in these Conway type universes, you also have a very big problem with lots of possible laws don't lead to any complexity and don't lead to anything interesting at all. Was that what you were going to jump in with?
Yeah. Basically, that's what I was going to say.
Yeah. Okay. So I wanted to discuss very just a bit, I think, because I think this is something that isn't made abundantly clear in a lot of these discussions, is to think a bit about what we mean exactly when we're altering these values of the parameters. So Luke's already mentioned that it's the process of doing theoretical physics, essentially, that what you do, we have these models, we have these parameters which aren't determined by the physical theories, they're not determined theoretically, and so we are well within our rights, let's say, to vary these parameters and to ask the if question: if we vary this, what happens? But one question I wanted to ask is how exactly we determine what range we should vary these parameters over. Okay, you could in principle look at the space from the value of this parameter from 0 to infinity, and then you can make the life emitting region as infinitely small essentially as you like. So I just wanted to see, or wanted you to say a couple of words about how we actually decide what ranges are worth looking at for certain parameters. Geraint?
I'll kick off. I mean, the most sensible thing to do is start from here and walk off in a particular direction in your parameters until things go pear-shaped, right? So you can explore the region around you and see what happens. And as I said, things get bad as you go off in particular directions. It's not a sphere; it's going to be some complicated shape. The question of the domain of what is acceptable in terms of the mass of the electron, for example. Well, you have to be guided by, other theoretical physics, right? There's nothing to say that the mass of the electron couldn't be 0, right? There's nothing in there that says that. There's a coupling between the electron and the Higgs field, and that coupling could be 0. And then there is a very hand-wavy argument about what you do at the upper scale, and you mumble something about Planck, and you sort of say, there's my range from 0 to mumble Planck. So you just take something as a guide from theoretical physics. But, as you said, you could take it to be infinite if you want. But again, you're running back into the problem of defining what do you mean by your probabilities here. I can tell you that over that range of 0 to Planck mass, the region of the electron mass, which is good for our universe, is pretty small, right? So, but there is no single way that you can do this.
So yeah, just chipping in, I think there's almost a sort of holding physics hostage response that can be made to this, which is if we can't get a handle on the free parameters in our model, then we can't test them. We want to be able to do things like, given the standard model of particle physics, what is the probability of this and that result of not just life, but this observation of what we saw in a particle accelerator yesterday, or the way that fluids work or whatever. You'd want to be able to do something like that. But if the match between the data and the theory depends on the value of these constants, as it often will, then you'd better have some sort of handle on what they might be or what the range of possibilities is, even a prior distribution given the theory of the value of these constants. Otherwise, you're not going to be able to say anything about how likely it is that we observe this, that, or the other if it depends on these numbers. So the theories better say something about the constants that are in them. So there's this objection that, well, if the range is infinite, then we can't, calculate the probability of a life-emitting universe. Well, if it works for a life-emitting universe, it works for anything. What that would prove, if it was a successful objection, is that our theories don't predict anything. There's because here's the theory and there's the number that goes into it, and then you take as the evidence a life-permitting universe. And if you say, well, we don't know enough over here to predict whether our universe will be life-permitting, well, okay, take that out as the evidence and put in what I just saw in my particle accelerator, and now try to predict that. Well, if it doesn't work for one, it doesn't work for the other one either. So I think there's a lot of mumble Planck scale. Basically, to fill in a few of those mumbles, very roughly, if you back of the envelope, how big would a particle have to be before it sort of became its own black hole, or before its quantum size was this sort of the same size as its black hole size, the short field radius, and you get to a number of a certain mass that does that. And it's not that we think that's what would happen. It's just at that point we go, well, probably run out of room for what our theories can be expected to predict at this point. So we better not go beyond there. And then you at least have that range to look at. And if we get a better theory tomorrow and we can go look further, we'll go look further. But fundamentally, if any physical theory, if it can't control its free parameters, then it's in a lot of trouble.
Yeah, just building on that, I think probably the most common objection to fine-tuning arguments from academic philosophers, so the most common objection on Twitter is the Douglas Adams puddle, but the most common objection from academic philosophers is something to do with these infinities. Like, if there ends up to be an infinite number of ways the constants could have been, making sense of probability starts to collapse for all sorts of reasons. But I mean, there are things both Geraint and Luke said there about, given that it seems our theories only operate between certain energy scales, it's not clear it is infinite. But even putting that on one side, it seems to me totally kosher to just start with a finite set of possible universes, as long as they're not cooked up, as long as they're not contrived. And we can do this by what we put into the background information in Bayesian reasoning. That seems to me totally fine as a way of avoiding infinites. So I don't see a serious objection there. And another thing people say is, well, we haven't tested all possible permutations, and that seems to me kind of artificially ramping up the standards of evidence here. All we can ever do is work with where we're up to, and insofar as we've explored a huge range of these possible permutations, possible universes generated from varying the constants, and the life-permitting universe is a very, very small portion of that, we should take that evidence seriously. As Luke says, maybe things will change as we continue to explore this possibility space. But all you can ever do, we're not going to wait till physics is finished. All you can ever do is reason and do some probabilistic reasoning off where we're up to at this moment.
And speaking of probabilistic reasoning, I think now is a decent time to get a bit more into how we can bridge the gap essentially between small parameter space, a small subset of your parameter space, and making the claim that the existence of life is improbable in some sense. So we've already said that the kind of probability we're working with really is epistemic, and that we're putting kind of, based on our current understanding of the world and our current understanding, what we should expect for the probability distribution across the parameter space. And usually, and I think this definitely isn't the case for everyone, as I think Geraint has mentioned, it seems to be sensible to adopt some principle of indifference and accept a kind of flat prior across the probability space, and then this across the parameter space, and then this translates a small region of parameter space into a similarly small probability. So are there any objections potentially to taking the principle of indifference, taking a flat prior, or is this the most sensible choice?
I'm not sure if there is I'm not sure if there is a single answer to that question. I think at some level we're almost back to the question of bringing your priors to the table. And I said I've been in arguments with various people where, you can't vary the parameters. They are the values they are. So the probability of the existence of life is 1, because that's the universe that we have. But again, if it was a different physics problem, what would you do? Right? How would you approach that problem? And I think you start with the principle of indifference. You have to. And until you get some guiding principle that says, oh, I'm going to downplay the probability here and downplay the probability there, then what else do you do? I mean, this is one of the things that I'm not 100% sure what people expect us to do at this point. And I think some people would suggest that we should do nothing, that this is an area that we shouldn't be investigating. If you can't do your probabilities, then walk away. But again, this is not how it works across the rest of physics.
Yeah, so if I can try and channel some of the people who have been throwing up these objections, and some very, very serious thinkers in science and philosophy of science throwing these objections up. So this is not the standard Twitter. So the idea is that if you have a picture of science where, the whole point of a scientific law is that it just summarizes, it's our best summary of the way things in the universe are observed to behave. This is Humean. It's, I think, roughly the idea of what's going on here is there's a way the universe is, it just is that way, and then we try to summarize that, and the best summaries we've got, those are just the laws of nature. Any sort of statement that appears in the most sort of informative and short and useful summary of the universe, that's what it means to be a law of nature. And the probabilities that appear in that are just, sometimes it's very convenient to summarize, a collection of things in terms of a probability distribution. So, for example, the digits of pi. You could calculate them all, and they all are what they are, right? But if you wanted to summarize them very quickly, you could say, all the digits 0 to 9 are equally probable. They come up equally often. And there's a way where you've summarized a very complicated sequence of things in a very short way. So the objection then would be, that's where scientifically we're justified in using probabilities, where we have a set of events we need to summarize, and we have probability distributions that describe those. And if that's where we're justified in using probabilities, then they point at me and say, what the hell are you doing? What do you think this is? And the response to that would again be, as Geraint was saying, there's more to physics. You've got to sort of, the way you arrive at, here's a possible way that we could explain this data. Here's another possible way. You've got to go and explore some possibilities. And the question that I think we can ask, and I think it's a sensible question, is what would we expect to find in a universe where we knew the standard model of physics that we have, but we didn't know what the constants were? Would we expect to see a universe like this? And that matters because that goes towards actually testing whether that theory is a good theory or whether we need something else beyond it.
Yeah, just adding to that, I don't think there's any disagreement yet, but I gave an analogy to a game show before where you're trying to guess which of the 3 doors the prize is behind, and there it might make sense to sort of measure your uncertainty. But so obviously one disanalogy with the fine tuning, we're trying to think, what might these constants have been? What's the probability that the constant has a certain value? But people might say, well, we know the values, you know, or at least to a certain approximation. And Geraint says, some people say, well, we should say there's a probability of 100% given that we know the values. How can we be measuring our uncertainty given that we know the values? But actually, it's pretty standard in Bayesian reasoning, in evidential calculations, to hypothetically ignore certain aspects of what we know. So to take a concrete example of that, and if I get the science wrong, people can correct me, thinking of Newton versus Einstein, predicting, for example, the precession of the perihelion of Mercury, doesn't matter what that is, but there's a certain bit of observable data that Einstein's theory predicts better than Newton's. Now, I've used the word predict there, which sounds like we didn't know this data, but of course, when Einstein came along, we already knew this data. So how do we make sense that Einstein's theory predicts it better than Newton's? Well, what you do is you hypothetically take out that data and ask, you know, how likely is it on Einstein's theory that we get that data? How likely is it on Newton's theory that we get that data? And we find out that it's much more likely on Einstein's theory. So this is pretty standard in these kind of evidential calculations, to hypothetically ignore the evidence to work out which theory fits better with the evidence. And that's essentially, I think, what we're doing in explaining fine-tuning. Yes, we know the value of the constants, but we hypothetically ignore that and say which hypothesis best predicts, makes that value of the constants most likely. So again, just making the point, this is what's going on in the fine-tuning arguments, whether it's the multiverse, God, whatever. I think is pretty standard way we think about evidence. You know, we've got mathematically precise understanding of how we think about evidence. So, and it fits pretty standardly with that, I think.
Yeah. Okay. Good. So one thing I wanted to discuss potentially is, so we look at the probabilities at this kind of epistemic level, but presumably behind our kind of ignorance at the moment of what it really means to value these parameters and change laws, behind this there is presumably an objective probability distribution over over the possible values of the parameters. I guess what I wanted to discuss is what such an objective probability, how we could make sense of an objective probability for each of the various values of the parameters, and also whether it should be kind of the fine-tuning going forward should try and start to find reasons, find a model of some kind that will predict objective probabilities for the range of parameter values.
Well, I mean, this is now we're getting into fundamental cosmology, right? I mean, what we don't know, we don't know how the universe making machine works, and if it ran once or 10 to the 120 times, we don't know how the universe machine works, and we don't know if the universe making machine has the values of parameters in this universe hard coded in, and so it had no choice in the matter, or if it does have a random number generator. And you've got those various possibilities. So saying what's the probability of the parameters, we are currently lacking insight into that mechanism for birth in a universe. We just don't know how it works. So I think we are going to have to push in that direction before we can really talk about parameters and distributions over parameters.
Any other comments, Luke?
Well, I mean, again, it's a question of whether we're thinking of. I don't like the phrase objective probabilities because I think it's, for me, ambiguous. But whether these probabilities are something that represents an actual set of things, a population, or whether they represent sort of the proclivities of a generator to produce one thing or another. So if I talk about the probability of rolling a 6, am I saying of all the times anyone has rolled a dice, that a 6 has come up roughly 1/6 of the time? But it's a statement about a bunch of things that's already happened. Or is it about the tendency of this dice and this surface that I'm going to roll it on? It has a 1 in 6 tendency to turn up with a 6. Or am I simply saying, look, I don't know which one of these is going to turn up? And that's a sort of the epistemic probability. So if we're trying to understand the probabilities here, I think it's at very least that epistemic one we can build on. If you upgrade it to there's a universe generator and it's actually made a universe, then you're talking the multiverse hypothesis, and you're putting forward a very serious statement about the way the universe is. That's more than just I don't know what's going on here, but you're saying there's all these universes out there and they generate different properties and all that sort of stuff. So I will it's a question of again, I think we can build. There's enough here to know that there's something to explain from the epistemic probabilities alone, just from the I mean, that looks weird, doesn't it? And there's enough there of there's an enormous range here, but to get life in this little range, and it's really a way of restating that things look pretty weird around and unusual around here. And if you want to upgrade those to sort of chances or actual frequencies, then you're making separate hypotheses.
And I'm going to jump in and just add again. This is one of the usual physics problems that we have is when people say probability, not everybody's talking about the same thing, right? Because Luke and I we were on a discussion yesterday about entropy. And when somebody says the word entropy, this person doesn't necessarily mean the same as that person. So the question of probabilities, you should start your discussion by defining what you mean by your probabilities.
Yeah, just very briefly. I mean, I think what we're always doing with science or philosophy is trying to work out which theory, which hypothesis fits better with our evidence in the sense of making that evidence likely. Which theory renders the evidence more likely? That's Bayesian reasoning summed up in a nutshell. Which hypothesis renders the evidence most likely?
Okay, right. On that note, then we can get on to what is potentially the meat of the discussion, and I think it seems Philip's been dying to start disagreeing.
Because he's a philosopher, of course.
That's where the fun begins.
So now I think what we're going to get into now is, does this fine tuning? So I think we're all agreed essentially that the evidence for fine tuning in the sense we've talked about is very good, is very solid, and so now it comes down to, does this observation require an explanation? And if so, what do we think would be a good explanation? And this, I guess, is the point where all of our views here are going to start diverging. So first of all, is there anything in need of explanation here? Why do we need to explain this fine-tuning phenomenon? Won't physics always look fine-tuned, possibly, until we have a theory of everything or a final theory?
I'll jump in. I don't think we need to make a decision ahead of time about whether anything needs an explanation. I think we can go searching for possible explanations and then weigh them up. And at the end of the day, if none of them look any good, then we'll conclude that, well, I guess it didn't need an explanation after all. But that's something we get at the end. I don't think we need to decide at the start whether things are in need of an explanation. Well, to put it another way, a good way of thinking that something might need an explanation is to think that you have at least a possible explanation that you should go searching after. On top of that, I think the fact that this fine-tuning thing is so striking to so many people is prima facie, on the face of it, evidence that we should at least look a bit closer.
How you? Sorry, Phil.
Go for it. No, you go for it. Go ahead.
No, I was going to say, how do you stop people sort of thinking about it anyway, right? And as Luke says, people's interest gets piqued, and so they go back and say, right, I go back to that if, and after that if is correct, then I need an answer. So I will think about an answer. And again, I think it's all part of the scientific debate. And as Luke said, if in 50 years' time we find out that it was all wasted effort, whatever that's meant to mean, then so be it. That's just that's the way the universe works. Sometimes we find out what's going on. Sometimes we go down the right path. Sometimes we don't.
Yeah, this talk of explanation, I think, is fine, but actually, I think it's sort of a loose way of talking about what's more rigorously talked about in terms of Bayesian reasoning, which, as I say, is all about which hypothesis makes the evidence most likely. Maybe just to take a vivid common sense example of that, suppose there's been a murder and Joan is one of the suspects and her DNA is all over the body, right? Now we've got two hypotheses. One is Joan is the murderer and another is Joan was 100 miles away. And let's say, the hypothesis that she was the murderer makes it very likely that her DNA will be all over the body, right? When she's strangling the person, it would have got all over the body. Whereas the hypothesis that she's 100 miles away makes it incredibly unlikely that the DNA would be on the body. So we go for the hypothesis that she's the murderer, because that renders the evidence much more likely. So I think actually Bayesian stuff sounds complicated, but it's this kind of reasoning that we do all the time quite easily. It's maybe like, grammar. When you think about grammar, it's very hard to articulate the rules of grammar, but you intuitively grasp them quite easily. So I think we all instinctively do this Bayesian reasoning. So that's what it's all ultimately about. Which hypothesis renders the evidence, in this case, the evidence of fine-tuning, most likely.
So let's go on to some suggested hypotheses then. So first up, is the multiverse hypothesis a good explanation for fine-tuning? Does fine-tuning as we've observed it provide evidence in favor of a multiverse scenario? Geraint?
I would say it's a satisfying solution. I mean, saying whether something is good or bad, I'm going to agree with Phil, right? I mean, you need to talk about this in terms of the evidence and your observations. But I personally find the multiverse idea satisfying. Firstly, because there is some theoretical background behind it, right? The notion of a multiverse is not only tied to the fine-tuning argument, right? There are multiverse arguments in relation to inflation, eternal inflation, etc. There are definitely complications that have not been sorted out, but multiverse can be a separate topic to that. And again, putting in some of those ifs, if you do get universes with different laws of physics, etc., then I think the multiverse does provide, as I said, a satisfying answer in terms of a physical solution, right? And as I've already said, the notion that physics is going to fix it, in my mind, is not a satisfying solution. So yeah, I'm happy with the notion of a multiverse as being an explanation of fine-tuning.
Luke, did you want to say anything about
disagree? Let me throw mine in, because obviously Phil wants to get in on this. But I think there's sort of, depends on the question we're asking. Why do the constants have values in our neighborhood which are suitable for life? Or perhaps more deeply, why does a universe exist at all which has just the right balance of constants for life to exist? So I think if there's a multiverse, it does provide an answer to both of those questions. In particular, the first one is just a selection effect, the anthropic principle, if you define it properly, which doesn't always happen. But basically, the fact that we are here, if you went around at all the whole universe, suppose there was a multiverse, and you went around to every time you saw a creature capable of answering a survey question, you got out your clipboard and asked them a question. What are things like in your neighborhood? you're not going to get a random sampling of the volume of space as a whole. You're going to get some very peculiar reasons because there's someone there to answer your questions. So you're not just going to get some random bit of the universe. The deeper question then of why is there a bit of the universe that is life permitting at all, given that it's so easy to make universes where they're that aren't life permitting. The multiverse provides an answer for that by just sort of brute numbers. If you have enough variation in enough universe, the right universe is going to turn up somewhere. So having the right universe turn up somewhere and ensuring that anyone who answers your survey question must be in one of the right bits of the universe, so to speak, seems to explain on those two questions everything we would want to explain. I think there's a deeper question, which is, is there anything sort of remarkable about the way this universe is as opposed to ways it could have been? And again, for me, the multiverse on that deeper question doesn't quite hit it because, I mean, we're sort of punting to ignorance a little bit, but more than that, what we'd love to do is to do with the multiverse what we've done with our laws. If we knew the deeper laws of the multiverse, we could say, oh, let's go change those knobs and dials and look at a number of ways the universe on this much grander scale could have been. We can't do that. So we're left with is there anything remarkable in our universe with the question we get from fine tuning. But on a scientific level of could we actually explain the values of the constants with a multiverse, I think that's what a multiverse should be aiming to do. And if it does that, that's no small achievement. These are constants of nature that haven't been able to be explained in any other way. If there was a convincing multiverse explanation for them, that would be something impressive.
Okay. Philip, I know you want to jump in. You've argued that fine-tuning actually doesn't provide evidence for the existence of a multiverse in some way. Do you want to talk about your argument?
Yeah, thanks. I think we finally get to a point of disagreement. So, well, it's not actually my argument. This is something that was argued for a couple of decades now by philosophers of probability. But it's a terrible thing that everything's so specialized now that although this is much discussed in the philosophical literature, if you look at the Stanford Encyclopedia of Philosophy's entry on fine-tuning, there's a whole section on this issue known as the inverse gambler's fallacy. But outside of academic philosophy, nobody knows about this stuff, despite, huge interest in fine-tuning for various reasons. So yeah, I'm glad that I've been trying to get this out to a broader audience. I had a piece in Scientific American people might want to look at, and in my new book, I'm trying to defend this idea. So maybe I'll just spend a minute or two explaining the basic thought. I think a good starting point is that in general, a multiverse explanation would be fallacious. So suppose the example I like to give, this monkey analogy, suppose I'm walking through a forest and I just see this monkey typing away on a perfect English on a typewriter, and he's just finished Hamlet. You think, oh my God, that needs explaining. Something weird there. Maybe it's a robot. Maybe it's a specially trained monkey. Maybe I'm hallucinating. What would not be a good explanation is to say, oh, well, maybe I'm in a multiverse and, it's so huge. Somewhere in it, there's going to be monkeys typing away. And if there's enough of them, if there's like an almost infinite number or maybe an infinite number, then some of them, statistically speaking, are going to be writing Shakespeare. And so that's what I'm saying here. That explains what I'm saying here. Now, I think that wouldn't be a good explanation, because what you want explained is this monkey in front of you, the only one you've observed, this evidence. You want something that explains why this monkey is typing English, and no matter what's going on in a huge multiverse, it doesn't have any bearing on making your evidence more likely. So the question is, why isn't it a similarly bad inference when we go from the fine-tuning to a multiverse? We think, oh God, the fine-tuning really improbable. Probably there's a huge multiverse, with enough variation, so statistically some universe is going to be fine-tuned. Why isn't that? If it was a fallacy in the case of the monkey, to infer to a multiverse? Why isn't it a fallacy in the case of fine tuning? Now, what people typically say is, well, the difference is the selection effect, also known as the anthropic principle, that we could not have observed a non-fine-tuned universe, right? Because if it wasn't fine-tuned, there wouldn't be life, there'd be no one around to observe it. Whereas we could have observed a monkey writing rubbish, right? And that's supposed to make the difference. Now, that clearly is a difference, but what I want to say is it's not a relevant difference. And so what is fallacious in the monkey case is also fallacious in the fine-tuning case. And a couple of ways I try to argue for this. One, a more theoretical discussion is I don't think there's any good theoretical account of why it would make that difference. And if we think about the ways in which selection effects make a difference in probabilistic reasoning, it just doesn't have an impact here. That's a more abstract discussion, but perhaps a more intuitive way into this is to argue by analogy. I think when we set up analogies in which we have a kind of artificial selection effect, we see that the fallacy is still there. So this is where I'm talking a bit too much, but I'll just give this analogy and then see what people think. So I have this Jane analogy. So Jane was conceived through IVF, and in her adult life, she discovers something a bit odd. She discovers that the doctor who did the IVF had a nervous breakdown around the time, and as a result of this, they did something quite peculiar. They decided to roll dice to see whether to fertilize the egg. They rolled 5 dice and said, I'm only going to fertilize it if they all come up 6. Luckily, they did. So the doctor fertilized the egg, and that produced ultimately Jane. Now, okay, Jane's discovered her birth, her existence relied on this improbable fact. Could she infer from that what I'm going to call the many doctors hypothesis? Let's say we know the hair doctor only did it once, and then they got some therapy. That she knows that they only did it once. But could she infer that there are many doctors rolling dice to see whether they're going to perform some IVF? I want to say it's clearly a fallacy there. All she has evidence of is that her doctor rolled dice to see whether to fertilize the egg, and whether or not there are other doctors doing the same has no bearing on that. It doesn't make it any more likely that her doctor would have done this, and that's her evidence. So there's I think I want to say this is a perfect analogy for the fine tuning. That there's a kind of selection effect. Jane could not have come to know about that her doctor had rolled other dice, had rolled, had failed to roll all 6s because she wouldn't have existed if that had happened. So there's a selection effect. Nonetheless, the fallacy is still there. So I want to say, in the case of fine tuning, yeah, it's true that we couldn't have observed different numbers, but I think that's neither here nor there. Our evidence, we should take our evidence to be that this universe is fine-tuned. That's what we want explained. And whether or not there are other universes has absolutely no bearing on that. So it's just a fallacious inference. That's the thought.
Am I allowed to jump in? Because
yes, you definitely are.
I've had this, and trust me, I don't think that this is the place for Phil and I to have an argument. But I'm just going to put the thoughts that I've had about this on the table, and maybe we can discuss this offline.
Yeah.
I realized the thing that was bothering me at the end of the day, let's go back to the monkey analogy, is that you turn up, you find a monkey writing Shakespeare, and you go, oh, this is kind of weird, because you've already got experience and knowledge of monkeys. You know about monkeys. Now, if before you had wandered upon that scene, you had been drugged such that your memory was more or less wiped, you knew nothing about monkeys, but you could remember Shakespeare, all right? And you turn up and you see this monkey sitting there, then what do you infer? Well, you could just say, oh, maybe this is just the only one of these creatures in existence. Or maybe there are more of them out there writing Shakespeare. Or maybe there are some of them writing Shakespeare and some of them writing gibberish. And you sort of go, oh, well, those are my possibilities. If it's that latter one, where the others are out there writing gibberish and I'm here with this one writing Shakespeare, how come I stumbled across this one? So but again, as I said, I'm not a philosopher, and this is not a debated society. But I do worry that and similar with the doctors, you start off with the knowledge that you assume most doctors don't go a bit crazy and roll dice when they're doing artificial conception. So if there wasn't that additional information, what would be a valid inference? And I'd say that there's more than one. So again, there are issues with the argument that bother me. I'm often not very good at logic puzzles, but I'm still thinking about it. But I said maybe Phil and I and others involved can have a discussion later.
So one thing that strikes me as maybe being slightly different with the Jane analogy is that in Jane's case, she couldn't have observed. It's true, she couldn't have observed anything different. There was only one chance to. One outcome where she would have been conceived, and so that's the only case in which she ended up becoming aware. But in the case of when we're talking about the fine-tuning of the universe, there are multiple. Even though most of the parameter space is or does seem to be life excluding, there are different possible values of the parameters that we might have encountered. And so what I think the multiverse, or what a good multiverse model is capable of doing, is given the life permitting range, there's that what a good multiverse should hopefully do is give the particular values that we observe a fairly high probability within that subset. Okay, in the whole subset, the probability of seeing a life-permitting universe may be very, very low. But within the life-permitting region, we should hopefully see values of the parameters in the life-permitting region that we should expect based on our multiverse, a good multiverse model.
Should I?
No, sorry. No, I was musing, so over to you.
Yeah, so I mean, I think that's what physicists have got in a habit of doing, who are into the multiverse. What their constraint is can we construct a multiverse model where fine-tuning is not so improbable in the set of universes in which there are observers, right? And that's the constraint. And for people who know about this stuff, you have Boltzmann brain worries about whether that's achievable. But my claim is there's no theoretical justification for that constraint at all. And what this ultimately comes down to, we've got to come back to the Bayesian reasoning. That's what I mean. Like, talk of explanation is kind of a bit loose. The Bayesian reasoning, and what it's an issue of is how should we construe our evidence? Should we construe the evidence of fine-tuning as our universe is fine-tuned, or this universe is fine-tuned? In the monkey case and the Jane case, I think we'd all agree that we should take the evidence in the particular case, like this doctor did this and this monkey. It would be impermissible to say, our doctor did this, and so infer the many doctors hypothesis, or our monkey did this, and so infer there's loads of monkeys. So the question is, why is it different in the fine-tuning case? Why is it okay in the fine-tuning case to say, no, our evidence isn't this universe, it's our universe? And the claim is supposed to be something to do with the selection effect. But why would the selection effect make that difference? I don't think there's any good account of why the selection effect makes that difference. I mean, the way selection effects standardly make a difference to probabilistic reasoning is they make us realize that our initial take on the evidence was incorrect. Sorry, I'm talking too long again, but just very quickly, a nice example from in the 1930s, the election. So just to give an example of a selection effect, in the election of FDR against Alf Langdon, I believe the Republican challenger was, there was a poll in the Reader's Digest that said that Alf Langdon was going to win massively against FDR, which was, of course, wrong. What went wrong was that the poll was conducted by telephone, and only wealthier Americans had a telephone, right? So, of course, so what does that? So there's sort of a selection effect because you were only really getting data about wealthy Americans because of the selection effect of using the telephone. So why does the selection effect make a difference? Because our initial take on the evidence was that it was more likely if Langdon is really popular and renders it improbable that Langdon is very unpopular. Once you take into account the selection effect, you realize actually no, it's more likely if Langdon is, the evidence is more likely if Langdon is popular among wealthy Americans. So you realize that your take on the evidence is wrong. But turning to the selection effect in the case of fine tuning, before we take into account the selection effect, we think, oh, life is really improbable. And then you take into account the selection effect, you realize we couldn't have observed a non-fine-tuned universe. It changes nothing. Life is still really improbable in our universe, right? Once you bring into account a multiverse, that it changes it. But that's the question: is it permissible to infer to a multiverse? So it just comes down to, just to summarize, it comes down to how should we construe our evidence? This universe is fine-tuned, or our universe is fine-tuned. In all analogous cases, it would be like this thing, not a thing. So why should the selection effect mean that we can now say I take our evidence to be our universe rather than this universe? I don't know what I haven't had a good answer to that. That's the puzzle. That's the challenge, really. Sorry, that was very long-winded again.
No, it's good. Lay it out. Let me have a crack at this. I find the Jane illustration to be quite confusing. So let's stick to the monkeys. Right. You walk into a room, there's one monkey sitting down at a typewriter, and you're told he's been there for ages. And he's just about to finish his book. And then bing, out it comes. What's the probability that you walk over and you read Hamlet? Well, extremely small. Good. Okay. So now there's an enormous number of monkeys out there somewhere, right? And they're all typing away at their typewriters, and then bing, they all finish. And then you go and pick up one of the books. What's the probability that that book is Hamlet? It's exactly the same as it was before. That hasn't changed anything. So now there needs to be a selection effect. The problem is there is a population. So the way that in physics, the way to think about a selection effect is that you've got a population that you want to know about and a sample that you actually know about. And the question is, can I use the sample to infer the properties of the population? I want to know how the whole population is going to vote on a certain issue. But I can't ask everyone because that would just be the vote itself. So I randomly select 1,000 people. Can I infer from the sample to the population? And if the sample is chosen in a way that is not representative of the whole in some way, say, biased towards richer Americans, for example, then I'm in danger of getting the wrong conclusion about the whole. So if I sample a random one of those bazillion books from the monkeys and I read not Hamlet, then that's hardly surprising. So the selection effect would have to be something like I'm able to choose from amongst those books the one which is most like Hamlet. If there's some sort of computer reading software that reads the book, and if it's Hamlet, then it shoots that copy out at you, right? So behind a screen, there's a certain number of monkeys, and since yesterday they've been typing away, and you don't know how many monkeys there are, but if one of them successfully produces Hamlet and you've got some machine that checks them all, then chow, that's going to be shot out of the wall to you, and you'll have your own very copy of monkey written Hamlet. And as you watch, pachow, one of them comes out of a hole in the wall. How many monkeys are behind the screen? You'd have to believe that there was an awful lot of monkeys there, right? because it's very unlikely there's one. What I think's going on with the Jane illustration, I think it's kind of confusing. I think the worry is that what we're confusing is, you've asked the question, should she believe that there are other doctors who use this strategy? And I think what's happening to us intuitively is we're comparing that hypothesis with the hypothesis there are other doctors who use the non-crazy strategy of just fertilizing every egg that they've got. So we're not, the intuitive, the voice in my head that says Jane shouldn't think that about those other doctors is the one that says, well, of course the other doctors won't use that strategy. They'll just fertilize every egg and not have a meltdown and use dice. And I think the sort of inference, if you take it out, it would be, should, the problem is that Jane exists and all the other people exists as well. Should Jane think that there are other fertilization events at all, given that she exists and it's a very unlikely event? That might be getting closer to the sort of a better analogy. But as I said, the Jane analogy is not clear to me.
Yeah. So again, I'm going to take 30 seconds and I'll put this in an email. I was going to replace the crazy doctor with a computer with a bug in it, and about choosing the which eggs are fertilized and which eggs aren't fertilized, because we know about doctors and we assume that they're not crazy and they're not going to do this roll the dice strategy. But that's additional information. I think we can hide it somewhere else in a computer bug, and it will not. Let me lay out my semi-logical argument later on.
Okay, that's very interesting. It seems like you're both trying to put it down to the low prior probability of the doctors doing this. I guess I'm inclined to think that's not what's going on. I mean, it doesn't seem to me to be that low a prior probability. It could turn out there's some strange cult where doctors, do this, and that doesn't seem to me that bizarre. I mean, it just seems to me it's not to do with prior probability of that. It's just to do with Jane wouldn't have any grounds for that hypothesis, given that her evidence, she should construe her evidence as just about what happened in this particular case. I mean, I think what the other thing Luke said is, so a lot of people have said to me, I was arguing with Tim Maudlin, quite well-known philosopher of physics, who argues very strongly for things I discovered. But his twist on the Jane analogy, and a few people have said this, is, okay, but she could have the hypothesis that her doctor rolled many times, and she'd have good evidence for that, because if her doctor rolled many times, it's more likely the doctor would get 5 6s. Now, okay, if that's what's on the table, she would have more evidence for that. I agree with that. That would make her evidence more like. Her evidence is her birth was very unusual, and her doctor rolling many times would make that more likely, would make her evidence more likely. But what's that analogous to in the case of the multiverse? That's analogous to our universe had many shots of getting fine-tuned, and the Lord of the universe is waiting, seeing until it's fine-tuned, and then going, okay, go ahead. That's a kind of weird design hypothesis. So what is properly analogous to the inflationary multiverse is no, her doctor did it only once. The question is, did other doctors do it a number of times? And I think it's clear that the fallacy would be present there. So I'd have to think about it a bit more with I think something similar was going on in Luke's monkey analogy. Yes, if there's I had my own thought experiment that is on YouTube somewhere with a terrorist who's going to kill you if you don't if a monkey doesn't type English. So I mean, let me just quickly think of that. It's so if there's a load of monkeys and the terrorist is going to kill you unless one of them writes English, then yes, you should say there's a load of monkeys, because whichever monkey types English, you're going to get away. The terrorist is going to let you go. But that's not the right analogy. The right analogy is the terrorist takes one monkey and says, I'm going to shoot you if this monkey doesn't write English. And then you're considering, are there other monkeys type English? So because yeah, I mean, Roger White, who initially came up with this, talked about the. I'm talking too long. I'll stop there.
Let me just chip in. I think the worry is that what we're comparing, we're trying to say, are there other doctors that use the same strategy? And I think the intuition that's there behind the scenes is, knowing that there are other doctors, it's more likely that they would use some other strategy, the right strategy, rather than the crazy one. So there's a comparison. The comparison that we're making in the Jane example is between a fine-tuned universe, but there's some other way of making universes which is almost certain, which are almost certainly life permitting. So the worry I have here, and I think this comes down to, I think I emailed you about this once, Phil. There's a word that I can't even pronounce. The thisness of this universe.
Hexaity, I think.
Hexaity. Yeah, I probably won't be able to pronounce that even in future now. But there's something odd going on with, is this universe, probability that this universe is life permitting, and I'm not sure what that means, because if by this universe you mean, how much detail are you including in this? Is it the one that I'm in? Well, if I'm in it, then it has to be life permitting. Is it the one with these constants? Well, then it's in the life permitting range. What information are you including in the thisness of this universe to then start talking about the probability of this universe being life permitting? And as I said, I got totally lost in not just yours, but a whole bunch of people's discussions on exactly this point. By the way, when I said, what the hell are you doing with probabilities? That was the voice of either Tim Maudlin or David Albert in my head. So yeah, that's very good.
Yeah, actually, Luke, yeah, that is precisely what a lot of the philosophical literature on this is focused on. That when the problem was initially set up, people sort of assumed that our universe might not have been fine-tuned, but how are we picking out this universe? Maybe, as you say, maybe we pick it out by its constants. Maybe our universe is essentially defined by its constants, or maybe we pick it out by its spatio-temporal origin or something. Well, my only contribution to this, my so far unpublished paper, which people can get on my website, does the fine-tuning explain the multiverse or something like that, is, well, actually, part of things being so specialized, none of the philosophical literature on this has brought in the science, has brought in the actual inflationary multiverse, which is the common version. And I think when you do bring that in, I try to argue it looks probable that on that view we shouldn't define our universe by its particular constants, but by its origins, the region of space-time that inflated to become our universe. And so we should take it, define it that way, and it is then an open question. We can discuss how likely it was that our universe might have been fine-tuned, but yeah, it's certainly a complex question. Could I ask Geraint something before we go for the multiple? Go on. No, go on.
It sounds like you've got some a priori map of the universe, and you just want to know what happens here. As if we're sort of standing in empty space going, boy, I hope a fine-tuned universe turns up here, right? I hope inflation puts the right electron mass around here, otherwise we're not going to be able to turn up here. And then oh, thank goodness so a multiverse in that scenario wouldn't help. If we fix a position in space-time and say, boy, I hope we get the right electron mass here. The fact that there's other bits of the universe, who cares? Because we've already picked our bit of space-time. But imagine I was making a video game and I wanted to get just the right conditions in Hyrule, right? And I decided I was going to just brute force it, use a Monte Carlo method, which part of my PhD thesis, never mind. And I was just going to make a whole bunch of universes, and then eventually, in a computer, and then when one of them is right, and I see people walking around, that's how I'm going to code up my universe. It seems to me that all of those other universes are doing some explanatory power. If the people who turn up in Hyrule, the bit of my video game universe that actually works and has people in it who can actually think about these sorts of things, if they considered a multiverse scenario, the fact that even I, imperfect creator I am, couldn't predict ahead of time where someone was going to turn up doesn't in any way change the fact that I've made it almost certain that someone's going to turn up somewhere, and those people will be in what looks to them like a fine-tuned universe.
Yeah,
that might
I
be
mean,
another analogy that's just not helping at all. But carry on.
I mean, I think it just comes back to, I think I can see how one can intuitively get some skepticism for what I'm trying to argue here. You think like, why are you focusing on our universe? Why, that seems very like, what's so special about that? But my argument would be that's what we always do. In the Jane case, the evidence would be her birth. In the monkey case, you'd say, our evidence is this monkey. I mean, the original example for the inverse gambler's fallacy was you walk into a casino and you see someone having an amazing roll, then you wouldn't be able to say, oh, there must be loads of people having crap rolls, because your evidence is this guy having hair roll. So that's what we do in all of the cases. And my question is, why would the presence of the selection effect make a difference here, such that we're now we don't say this universe is our evidence, we say our universe. But can I ask something about the multiverse to all of you, really? Is that just, I just got one thing I'm always stuck on is this move to, so you've got eternal inflation, that you've got all these universes, but what you ultimately need for fine-tuning is what I call landscape eternal inflation, that the constants vary in different universes. I'm just curious, and what I always find hard to pin down, just setting aside fine-tuning, is there any other motivation for holding that the local physics varies in different universes apart from fine-tuning? So I appreciate that string theory gives you that possibility, because the string theory, you can make theoretical sense of local physics being different. But is there any reason to think it, theoretical or otherwise, apart from fine-tuning, to think local physics would be different in different universes? So I'm taking for granted eternal inflation. Is there any theoretical reason to think that local physics is different in the different universes apart from fine-tuning? I just like people's expert opinion.
In a hand-wavy way, yes. In the sense that every snowflake is different, right? So what you've got is that universes crystallize out of eternal inflation, and the way they do that is, they start off in some lovely high energy perfect state, and they make their way down into a low energy state, and that low energy state is like the formation of a snowflake, right? So the string theory one is the way that the Calabi-Yau manifold folds itself, or whatever you want, however you want to put it. So we already know that with our universe, we've gone through a series of cooling and symmetry break-in, and that cooling and symmetry break-in is set, as somewhere is related to the fundamental constants. So in a hand-wavy sense, yes. Now, it could be that every universe that condenses out of eternal inflation cools in exactly the same way, and every patch is exactly the same. You cannot say one way or the other. But, we're then left with the question of why our particular fold-in manifold for this universe, and why is that everywhere? Why? And again, you need a theory above to say, why does every patch cool down and look exactly the same?
So just to get clear, so as I understand it, in string theory, the constants depend on the shape of the high dimensions that the strings vibrate in. And you seem to be saying there, Geraint, this is just me asking your expert opinion, I'm not challenging you, that the high dimensions, the shape of the high dimensions would vary depending on how it cools. But why do we think that? I don't really know what I'm asking here. Why couldn't it be just they just have the shape they do, and that's that?
Right. So the original goal of string theory, of course, is that it would be a theory of everything, and that it would be a single theory that would explain this universe, right? And there's the and I'm going to put my hand up. I'm not an expert on string theory, so if any string theorists watching, I do apologize. But of course, what they find is that the low energy states, the physics as it condenses out, they were hoping that there would be this single shape there, but there's not. There's this landscape. There's a possible landscape. So everything starts off in this sort of smush, featureless, and as you cool it down into the physics, you end up in your particular group of physical constants, etc. So again, either there's some stochastic issue there, right? So as you cool down, in the same way that snowflakes are different, right? As you cool down into one shape or cool down into another shape, or everything cools down in an identical fashion, and every patch has the same laws of physics. Then we're left with the question of why is that particular shape that it cools down into favored? Why is it chosen? And again, I don't think string theory has an answer for that, and I definitely don't.
Thank you. That's very helpful.
There are a minority of voices, Tom Banks is one of them, who argue that you don't have 10 to the 50 different ways the universe could have been. You have 10 to the 50 different string theories. Yeah. I mean, so you think of just a much more ordinary equation of physics, Newton's laws of gravity, GMM on R squared. There's the universal constant, and then there's, the distance between the things in the universe. So some of the things in that equation change. The mass is here and over there, and more mass and less mass. And then there's this universal constant G. So I can move things around to change the distances between things in the universe, but there's nothing I can do within Newton's theory. I can't, throw something really hard and change the universal constant G. So there's a question of what is, this is a question of what is string theory? What the heck are we doing? These different manifolds, are they things that I could, again, just stick the universe in the oven for a bit and heat it up and cool it off and these things will change? Or is it like a universal constant? It just, when you specify that number, you're specifying a particular set of laws. I think, as I understand it, Tom Banks is a slightly minority voice on that, but this is just sort of highlights that string theory is a bit of a very weird kind of thing. It's almost like we've got hints of a theory without knowing its fundamental principles yet.
Right, I'm quite conscious of time. So the one question that I would like to get to, if I know you need to go, never mind. But just so we've talked about a naturalistic hypothesis or an explanation for fine tuning. What could we say about whether a non-naturalistic, something like a creator or a god, could this be a good explanation for fine tuning?
A small question there.
Yeah. Just a small question tacked on to the end. Yeah.
Popped into 5 minutes. So let me get some very brief thoughts on this. The sort of explanation that we give when an agent, you might say, explains something is that there's a whole lot of ways that the ink could have gone down on this whiteboard. Why is it this particular way? Well, it's because I had the words, that phone number in my head before I then wrote it down on the board. So when you have, in the most general terms, an agent, it's possible that something is it's understood ahead of time, so that a way things are now is because it's foreseen that will happen ahead in time. And so of all the possibilities that we sort of see laid out around us in the laws of physics, it would be possible for someone, because we sort of do it ourselves, to say, all right, let me look around at all the masses of the up quark, the down quark, and the electron. All right, most of these are boring. Oh, hang on. I've found one that will actually make a periodic table in chemicals and some interesting stuff. And so I might make that one happen. But it's that the sort of most basic thing about being intentional is that the consequences of a possibility can be considered before it's sort of put into action. That's the sort of explanation that it's supposed to be. That the remarkable thing about fine tuning is that these constants were what they were at the beginning of the universe, and the if you just looked at them, then they just appear like any old other constants. But what we've worked out, and what we're the beneficiaries of, is that give it a couple of billion years and I'll make a hummingbird, right? The universe will start producing some rather interesting stuff. Whether that's actually convincing to you is going to depend an awful lot on whether you think that the most fundamental kind of thing could be more like a mind than like matter. So there's a question of what sort of prior you put on naturalism, that everything is ultimately matter-like at its base level, or whether sort of, I guess generally, I would just say theism. I guess idealism might be the more general term, but whether ultimately things are more, the ultimate reality is more like a mind than like matter. I think there's more to be said about this than fine-tuning. Just for the most basic point being, on a prima facie level, the people who look at fine-tuning and go, oh yeah, that looks great, tend to be theists. And the ones who go, oh, what the hell is going on around here, tend to be naturalists. And that's at least fun. There's a quote, I think it was Alistair McGrath, who just said he'd given some talk and mentioned this stuff about fine-tuning, and someone said to him afterwards, I'm not religious, but something weird is going on around here. And that, that would be my summary.
Luke and I laid out our discussion of this in the back of our book, right? So, I do not come from a theistic background, and for me, again, to do with satisfactory explanations, I wouldn't be too averse to the simulation hypothesis. I don't think that's completely wacky. It's just very, very wacky. But again, the notion of the creator side of things, who cares about me and this planet, etc., it doesn't do it for me.
So one thing that strikes me about it, kind of in what Geraint's saying, in terms of having a satisfying explanation, there is the size of the life-emitting region in these fine-tuning examples isn't just a single point. It isn't zero-dimensional. It always has at least, there are some different values that do seem to allow for life. So because that's the case, it seems to me that I won't have a satisfying answer to why the parameters take the values that they do, unless I have a model kind of like the multiverse, which can show me that, or that what you'd be able to derive from it, that observers such as myself, the most likely or very likely parameter values that they'd end up seeing are the ones that are in our universe. With the kind of creator explanation, it seems to me kind of vulnerable to one of Einstein's kind of questions, which is he wanted to know whether the designer, whether the creator had any choice in the creation of the universe. And it seems like if you have a region in parameter space, or an area, which isn't just a point, then it seems like there were choices that the creator could make. Now, on some theologies, you think that God has certain intentions and certain aims for the universe in the long run, and perhaps God is perfect, then perhaps that predicts a very particular point in this phase space. There's one point that's optimal for God's intentions and God's intentions and what God wanted to do. And so perhaps the Godish hypothesis could be very predictive in that it picks out one point, and if our parameter values are not that one point, that's evidence perhaps against this, at least this idea of God. But that's the kind of thing which bugs me most about the kind of creator hypothesis, that it seems like there's still choice. There hasn't been a clear reason or explanation for why the parameter values take the exact value that we find them.
I think it comes down to just comparing whatever possibilities you think you have on the table. I mean, it's entirely, well, you know, we have limited knowledge anyway. So I could just say, look, you get as much understanding and explanation as you get, and then that's it. And then if you've gone from all the set of possibilities to, okay, they're all still possible, but this set's really interesting, so maybe that's more likely. This set here would have, as Robin Collins puts it, embodied conscious agents, and so we might give that a much higher probability than the rest, or comparable probability to the rest. It wouldn't really matter. If that's as much explanation as you get, then so be it. Okay, that's all right. That's our cards on the table. You put your cards down. Let's see what naturalism's got. Let's see what brute force naturalism has got. Or let's see what these other ideas have. So it's not. There's an open opportunity, yeah. If someone could just sort of sweep in with some grand metaphysical principle that absolutely nails this is the way exactly this universe has to be, and it couldn't possibly be different, then bring it on. You've beaten us all. Well done. But we'll come to that when someone lays that on the table.
I'm sure you want to say something, Philip.
Yeah. So I mean, I guess my view on this is my explanation of fine tuning is different, both from Geraint and from Luke. So I think what is striking about the fine tuning is that it's the constants are in that very narrow range, which is compatible with a universe which allows for great value, right? Which allows for complex life, people falling in love, writing poetry. Most of these other universes would have little or no value in it. So I think what we should take from that is that the fine tuning is evidence for what I call the value selection hypothesis, that the values of the constants are as they are because they're conducive to a universe of value, that they were in some sense selected for because they are conducive with the universe of value. Now that's really weird, unexpected, but the Enlightenment ideal is that we should follow the evidence where it leads. And I think most people are in denial about this for cultural reasons, because we've got used to the idea that science has ruled out God or anything like God, and that's what we've got used to. The evidence changes. I think people cannot handle that for cultural reasons, and it will take a long time for the culture to catch up with the evidence. But now, so I guess I'm closer to Luke, because God is one way of making sense of the value selection hypothesis. That a good God selected the values because they allow for value. But I don't like the God hypothesis because of the familiar problem of evil. Huge debate. I don't think it's plausible at all that an all-powerful good God would create a universe like this. But what I'm exploring in my work at the moment, this book I'm writing, is there's a huge range of other options. So just very quickly, 3 options. One is what Geraint has already pointed out: a non-standard designer. Could be the simulation hypothesis. Could be a bad God, a limited God, an indifferent God, or something Thomas Nagel has explored in his book Mind and Cosmos: teleological laws with purposes built into them. Or another view I've explored in academic and popular work, cosmopsychism. If the universe is conscious, maybe it in some sense fine-tune itself. So there are a variety of, I'm allergic to dichotomies. People get stuck in dichotomies of thought, like US capitalism or Soviet communism. Which do you believe in? God or Dawkins? Whose side are you on? And I think there's a huge range of middle way options here. So this is what I think is that I think basically there's something the theists and the atheists are in denial about, right? The theists but that's a very ad hominem way of putting it. There's something they can't explain. The theist can't explain evil. The atheist can't explain fine tuning, like the traditional meaningless universe atheist. Just the unbiased mind looking at the evidence should say there's something in between here. There's some value playing a role in shaping the early universe, but it's not the traditional theistic God. Hugely underexplored. That seems to me the way to go, I think. Anyway, it's talking too long again. Sorry.
No, that was about right.
Geraint, did you have a chance to say something on this topic? I can't remember. It's
No, I don't think I do. I mean, I am in that purely, mechanized universe without requiring any kind of extra hands to sort of shape it. Unless this is simulation hypothesis, I said I can dig that one, mainly because I run computer simulations and I think they're cool.
Yeah, I just can I say one more thing? I wanted to. Sorry, I've already talked too long, but Matt's objection about theism doesn't explain anything because we have to say, well, what are the intentions of the designer? That is also a common objection among academic philosophers. But I think I think the way to answer it is to go the value route. Yeah, if you're just thinking of like a designer that could have any intentions, but the hypothesis would be there is a good designer, or moving up more generally from the design hypothesis, there's something that is pushing in the direction of value. So I think that makes the hypothesis predictive in a sense, not in a traditional scientific sense, but it makes it in some sense predictive. And then just finally, yeah, of course it depends whether the multiverse is a good explanation, but if this is the final thing I want to say, if I am right that the evidence of fine-tuning needs to be construed as this universe is fine-tuned, then we're comparing the multiverse hypothesis to some goddish hypothesis. Then the goddish hypothesis clearly wins because that renders the hypothesis that this universe is fine-tuned more likely, whereas actually the fine-tuning hypothesis, the multiverse hypothesis doesn't raise the probability that our universe is fine-tuned. It raises the probability that our universe is fine-tuned, but doesn't raise the probability that this universe is fine-tuned. So obviously a huge debate about how we should construe the evidence. But if I'm right on that, we've really got to go for something goddish, if not the traditional god.
Yeah, I think what I'd say is that what concerns me about the goddish hypothesis is that its prediction not in the kind of is not as precise as say a scientific prediction would be, and I think that I don't see the fine-tuning of the constants as being a problem where we need to say that we need to start thinking, perhaps the scientific method of predicting these things is going to fail and we need to look elsewhere. It feels to me to still be a very good bet to proceed with science. And to be fair, theists who think that there are a non-naturalistic explanation will proceed with the science anyway because they're good scientists. But it seems to me I'd put my bet more on that we will be able to find, say, at least a good scientific reason, not that the constants definitely take one value and that's it, but that if you're an observer, then the constants that we measure in our universe are a likely set of constants to observe. And I think that science definitely has the scope and the ability, and I would bet on that it is going to provide that kind of answer. And then where I then disagree with you is on the question that you think is the one to be asking. I don't think it's the right question to be asking, why is this universe fine-tuned? The question that I think is the right one is to say, why are the constants that, as an observer, if I'm an observer, what constants would I likely observe? And hopefully the answer to that question is a suitable multiverse model. The answer to that question would be that these constants are at least fairly likely.
But Matt, doesn't that sound like the very definition of a bias, that you're not going to consider the value selection hypothesis until a different one comes along? I mean, it's not that I'm not going to consider it. I definitely consider it. I think it's an interesting hypothesis, but I think that
you're placing your bets.
I'm placing my bets, and I think I've seen science's track record, and I think it's still got a good lot to give, and still on this question as well. I think if the scientific attempts to answer this question started looking more hopeless, perhaps we're getting towards that stage. There were some very preliminary investigations on whether you could put a good likelihood on the value of the cosmological constant using anthropic arguments and the multiverse hypothesis, which didn't provide probably an okay answer, but not an amazing answer. But I still think that this is, to me, it seems like the way to go forward. This is a question about how the world is, the constants of the world, they're constants that we have in physics. It feels like to me that we should be pursuing this avenue. We can consider other avenues, sure, but I still think that this is the clear avenue that's going to yield the best results.
I mean, the thing is, we don't have to say, oh, it's definitely this one. We tend to talk not about belief, but about credence, like how much credence you'd give to this hypothesis and this hypothesis. To my mind, yeah, everyone should give some credence to the evidence changing. But to my mind, I think anyone who doesn't give a significant credence to some goddish hypothesis, I just think that is just irrational cultural bias. Okay, you might say, well, actually, I think it's more likely it'll go this way, but to just say, we don't have to stop doing the science, but just to say, no, I still think that's like 0.1%. I think even if I'm totally wrong about the multiverse, even if the multiverse is on the table, it tends to be all the atheists say, oh, well, it's the multiverse, and all the theists say, oh, it's God. I just think anyone who doesn't give look at the fine tuning, this unexpected data, and give significant credence to both, to the goddish hypothesis, I just think that is irrational cultural bias. I think anyway.
Right, so we have hit the 2-hour mark, so perhaps we should wrap things up. Thanks for all three of you being on this for so long and sharing all your fascinating, interesting views and insights. I think hopefully everyone's enjoyed it. I've certainly enjoyed it. Any closing comments?
As Geraint said, the last chapter of the book, we at least hash some of this out. I've got a more recent paper called A Reasonable Little Question if people want to follow that up. But yeah, I mean, it's the start of a long conversation.
Yeah, I've got
just to say
thanks to that.
Thanks, Matt, for having us on. I kind of invited us on, didn't I? And thanks so much. I'm sorry, I've talked too much and probably spoke.
You haven't, Phil. You laid out your case. That was fine. I enjoyed that a lot.
It's been really useful for me to have all your expert opinions on this topic.
It's great to have all of you on. I've read plenty of what you guys have written before, so it's lovely to have you on and witness this discussion.
Excellent.
Thanks.
Thank you.
Thank you very much.
All right, we'll go off there. Thanks, everyone. Hope you enjoyed.
Bye.